My name is Kyle Nitzsche. I apologize for the poor video quality here, and I'm about to switch to a presentation. I'll give you the URL for that. Here we go. I'm going to switch over to screen share. Might take me a minute to find the right one. Let's see. I have to switch around a bit. Hang on a sec. To the entire screen. Okay, Mike, can you see the presentation?
Yep, your screen sharing's working.
Okay, good. Okay, so let's see. I'll go into presentation mode here. Just a few more preliminaries. Okay, I'm about to give the URL for this. So, yeah, this is a little presentation on location awareness for scopes in the context of the 1410 framework. My name is Kyle Nitzsche. I've been working at Canonical as a software engineer since 2006. And I'd like to apologize in advance if I make some less than pleasant sounds during this. I got a flu recently and I'm still not quite over it, so I might cough a little bit. I'll try not to. So this presentation is available if you want to follow along or look at it later. The URL is now on the screen. I'll give you a moment to well, you know what I should do is probably put that in the Google Hangout. Hang on a sec. We're actually into the IRC. Okay, I just pasted the URL to the presentation into Ubuntu On Air in Freenode. So let's take it from there. Back to presentation mode. Okay, so what is this and why? What is location awareness? Well, the shell, which is really Unity, and it's Unity 8 and its various aspects, provides into the scope runtime framework location data, and that location data is available to the scope. That location data includes lots of different bits of information. For example, latitude, longitude, country, country code, region, region code, city, city code, and more. And not all of them are always available. So we have to take steps when coding to handle the cases where it's not available. But this location data is available to your scope, and you can access it. And then, well, what can you do with it? You can display it directly in your scope, although that's not usually done, but it certainly is possible. You can use the data to query a web API. That's a very common case. You get your latitude and longitude of the the user's device, and then you build up a web query using the latitude and longitude, get results, parse them, display them to the user in your scope. Very common. Or you can do anything else with this location data that you can think of. So there's lots of things you can do with it, and it enriches the user experience in the scope. Right, so the most common use case, though, so far, is, in fact, to get the latitude and the longitude, as I just said, to create a URL and to query a web API. Now, I provide an example here of a web API URL, which doesn't always work. The reason it doesn't always work is because if you look at it closely, there's a username in that URL. It says username equals demo. This is from geonames.org. And sometimes this will give back an answer that says, hey, demo was used too many, accessed the API too many times today, try again later, or get a paid for account or whatever. But this is just an example. So you build up your URL, you send it off, you get a response. This response can be different things. It could be JSON, or it could be XML, or whatever. You parse that response, pull out and display the selected results, the ones you want, in your scope, and there you've got yourself a rich user experience, location awareness. So that's the most common use case. What are we going to cover here? So we're going to discuss all the key points in the code. And the code is C++ by referring to a branch. And here's the URL to the branch. Perhaps that should go into the IRC as well. Branch for. So what is this? This is a scope I wrote yesterday, which basically, it works. It gets the location object. It does it in a way that's going to handle results if they're not available. It displays two different categories, one for data from the location object, and then it goes ahead and it creates a URL to query GeoNames API and get some data back, and it displays that in the second category. So I'm going to go through all of the code and all the key points there. This presentation today is not specifically about scope coding per se. It's not about CMake. It's not about using the IDE. I assume those are covered elsewhere. So let's see. Let's carry on here. Okay, the demo scope. So here's a screenshot of the scope that I threw together yesterday for this. And basically, you can see that there are two categories. The top one, the title is from search metadata dot location. So that's the category title. And that top category has 5 results in it. And then each result has a bunch of, a couple pieces of data that I've gotten right from the location object. And then there's a second category down below. The title is country info. And there's one result. This category is populated by querying the web API. So this shows you, the basic anatomy of a scope. You've got categories, and then each category are the results. Okay, so that's pretty much what we're going to code. So next up. Okay. I'm going to note that I think David Calais, forgive me if I pronounce his name wrong, put together a tutorial on developer.ubuntu.com that goes into a lot of the basic information here. I know he mentioned this, but nonetheless, duplication notwithstanding, let's just hit all the high points. So for your scope to consume the location, excuse me, the location data that's provided from Unity through the scope framework to the scope any card or any file has to contain the location data needed equals true key value pair right there in bold. Without that, it ain't going to work. Note that it has to be in the scope config section of the any file. There's also an appearances section for scope appearance customization. So you got to put this in. And once you put that in, when you run the scope, you'll see the scope settings automatically has a toggle for the user to enable or disable location awareness. That's just automatic. Just thought I'd mention it. Okay, so now we're going to get down to the C++ code here and how it works. And I'll point out again that all of this is in the branch. You can get the branch and build it and run it, and it should work for you too. So to start with, the scope class itself has a search method. Every scope class has to implement the search method. That search method receives a search metadata object. By the way, I provided the link under 1 there to the developer.ubuntu.com API doc for the search metadata object, which you can look at your leisure. That will show you, obviously, all of the methods and etc. that you can use as a developer. So the search metadata object is critical because it has the location method, and that is what returns the location object. So the scope search method receives the search metadata object from the shell. It passes it to the query constructor. So when you build your query class, you pass it the search metadata object. And then in the query class, you can then use the search metadata object to use the location method and to get the various data that you want. So that's 2 key classes, search metadata and location. And I have the links to both of those for the API docs. And here's the code in the scope class. So you can see the first line shows, this is in scope class. There's the search method. And we can see that that method receives the search metadata, named locally as just metadata, so it's the address. And then right below that, in the search method again, we create our query object. And in creating, we pass the metadata object to the query in its constructor. So all of that is in the scope class, and once it's through this part, your query is constructed, and it now has this metadata object, and it can use it. Now if we look at it in the query itself, so now we're switching over to the query class. This is the query constructor. And we can see that it's receiving the search metadata. And it's receiving the metadata by reference, so it's the actual search metadata object. And then right below it, the second bold part, I'm initializing a local variable that was declared for the class in that class header file, the query class header file, S metadata for search metadata, and I'm initializing it with this search metadata object. So now my query class has the S metadata, which is the search metadata object itself, and it can use it. So I think that's fairly clear. Now your query class has, and must have, a run method. That's a good place for you to get the location object off the search metadata. By the way, I'm just going to point out here that there's search metadata. There's also action metadata. It's a different class in the API used for other things, but it's easy to confuse the two. Often in code I've seen the class variables just be metadata, and you're not sure whether it's search metadata or action metadata, which is why I named the query class here S metadata, just so I can keep it clear. Also, I'll just point out that what I've just described to you is how the search metadata object gets passed to the scope class, and from the scope class it gets passed into the query class, so you have it. But you can also create your own search metadata object. And then set the various location attributes if you want. Although that's sort of an advanced feature, it is possible to do that. I'll move on from there. Okay, so in the query run method, you can use the search metadata object to get the location object, and then use that to get the data. Now it's important that you do this wrapped inside a TryCatch expression, so that you catch the not found exception. It's possible that when you try to get the location object, that it'll throw an exception. And if that happens, you want to catch it so your code doesn't die a horrible death while the user is sitting there wondering how to get to the nearby train station in the rain. So to catch that not found exception, you do need to include the Unity Scopes scope exceptions.h header file. I'll show you the code in the next slide, I think, or the next couple of slides. So the first thing we want to do is we want to declare variables. We're in the run method of query, and we want to declare some variables that will have scope in throughout the entire run method. We don't want to declare these in the TryCatch area because those would just have local scope to there. So we declare them outside of the TryCatch. And these variables that we're looking at here, this is most, but not all, of the bits of data you can get from the location object. Latitude, longitude, country name, country code, region name, region code, city name, altitude, area code, postal code. It's a couple more. I'm not quite sure what some of these do. I'm not really sure what the difference is between area code and postal code, but they exist, and in this demo we're gonna get and use these. So declare the variables. Now I've removed a lot of the code with an ellipse here. I'm just showing this is the TryCatch expression. So basically we're using the search metadata dot location. Well, the search metadata is location method to return a location object. We're trying to do that, and if that fails, then we're catching a not found exception. And in this case, I'm just logging a critical events using Q critical, and which causes the scope to quit critical. But you might want to do something more graceful. So there's the TryCatch critical piece of code there for real scopes out in the wild. Okay, now inside that try block there, we're simply going to go through and see if and use the location object to see if each piece of data we want actually exists, and if so, getting it, otherwise giving it a value. So sometimes, like I've never seen when location is actually working, I've never seen a latitude and a longitude not being available in the location object. But I have seen some pieces of the data not being available. Like you can get a country name and a country code, a region name and a region code. Sometimes these are not available for the given latitude and longitude. I'm not sure why, but if you're planning to use it, you want to do something like this to use the has country code or has region code type methods in the location object to see if it's there and get it. So I've removed all of the detail code in this try block where I basically do that for all of those variables I declared. It's in the branch, so get the branch. You can see all 15 or whatever pieces of data being accessed in this way. Okay, so after we've got the data from the location object, naturally we need to display it in the scope. And I'm not going to go into great detail about this, but as we know, scopes, the way scopes are organized is they have categories, and then the categories have results, any number of results. Each category is built from under the hood from this JSON, the template. And the template says some critical things about what the category is. And a couple of the points here, which are perhaps of interest, are I've put in bold here. The first one being that I'm setting this non-interactive equals true. What that means is that there's no previews in this scope. In other words, if a user taps on a result in the category, nothing will happen. This will not cause the scope to switch over to a preview view. It'll just stay right there. So the results within this category are non-interactive. Collapsed rows is basically, sometimes you see more and see less. This is the number of rows before it just doesn't show anymore and it says see more or see less. But you get the idea. Down below is the components, and these are the data items really of sorts. into which you stick your data. And in my case, I'm just using a single one, summary. There's a set of components, as we know, that are allowed, and summary is one of those types. Basically, I just populate my data into the summary field using text that I've marked up with bold and put in line breaks, so it just lines up looking the way it does. So there we're going to define the category, we're defining the template. And then before we can put results in, we have to actually create the category renderer and then register the category. So the first line there is we're creating the category renderer using the renderer string that we just defined. That's the JSON. And the second line of code registers the category. And if we look at that in a little more detail, we have reply. And we're calling the register method on the reply pointer. Well, this reply pointer is received in the query run method, and I show that right there. Query run, it receives a search reply proxy, which is a pointer to a search reply. So the search reply has a method, register category, and that's how, when you create your category, you tell the Unity, the shell, about your category, and you register it in. There's the link to the SDK API docs for the search reply. And basically, the register category method has some different signatures. It takes the category ID, which I'm setting to location API, a title, which is from search metadata dot location, an icon, which is null here, and the renderer, which is really the category renderer that we just created. So there we've created and registered our category. Now we're ready to populate some results. So here's the first result. What we're going to do here is, since the first part of this scope is just sort of creating a bunch of results, each one with some location data that I've just got from the location object, I just manually go through, create a result, put the data in, and push it. Create another result, put some data in, and push it. Create another result, and put some data in, and push it. So here's the first one, the result that shows the latitude and longitude. What's of interest here? Well, first I create the categorized result using the cat, which was what I created in the previous screen. It's what you get back when you register a category, cat. So moving back to where it was, create the categorized result, and then in this result, now what I'm going to do is actually populate a string using the QString here for convenience. So summary is the string that I use throughout all of this. I just put in some results. So the first one is the latitude, and that first line there, it basically puts in the word latitude, a colon, and then it puts in the actual latitude, LAT, which I previously got from location object, and then a line break. And I'll note that I used a strong function here. It's just a local function in the scope I wrote. It's shown below. You just call it, you pass in a string, and it wraps it in strong markup. So that's why my scope, when you look at the results, like longitude is bold, and then it shows the longitude. Latitude is bold, and then it shows the latitude in non-bold. Okay, so we create that summary string, just putting it all together, and then in the result itself, which is result lat long, in the summary field of it, we set it equal to this summary QString that I just created. Of course, the API takes standard strings, so I have to use the toStandardString method, which is a QString method, to convert summary into a standard string. Every result has to have a URI, even though they're not used sometimes, so I just set it to ubuntu.com here. And then reply push, and I push the result lat long. So that pushes this result. This result contains it knows what category it is, and it pushes it back up, and boom. That's all I need to do to hard code a result and push it. I do this a few more times. So for example, here's the country info. The details are all the same here. I'm just using the country name and the country code. So I create a new result, start with summary string. This time it doesn't start with plus equals, just equal, so it gets a new value. I put in all the markup I want. I set the result country, categorize result, summary field to my new string, set the URI, and then push it. I do it again for region information. Pretty much straightforward. And there's a couple more in there which were shown in the original screenshot of the scope, but that's it. So hard code the results. I think I already mentioned this point. Non-interactive in the renderer template means that there's no previews. So if you look at the preview class in my branch, it adds no extra content. It's just the class bare essentials, not needed in this case. Okay, so that covers the first part of the scope, the first category of the scope, which is just basically getting location information, wrapping it in a TryCatch blocks, and then manually creating categories and results and pushing them. Now I'm going to take a quick run through building a query, a URL, and then querying that API, getting the result back, parsing the result, and then building a simple result in a new category and pushing it. This is, the most common use case, so I thought I'd mention it here. So to start with, we're going to create the second category. The scope has two actual categories, one for the hard-coded, the other one for the web stuff. They use the same template, the same JSON definition. So I create a new one here. Well, I guess I'm not showing it. I got ahead of myself. That's next. So let me start with, here's where we create the URI or URL, whatever, that contains, that we're going to use to query the web. So it's a geonames, and I just populate in the latitude and longitude, lat and long, into the URL. And I don't think there's too much else to say about this. So it's called lat long URI, and we'll use that later to query the network. All right, here's the creation of the second category. It's using the renderer template at the end of that first line of code. The ID is country_info. The title is country info. Look at that, I actually wrapped it in get text. And then we create a categorized result, and we're naming it result. So as always, when the result is created, you tell it what its category is. In this case, it's cat web API, and we get a result. And that result we're going to use to populate with the data that we get back from the web query. Okay, so this is sort of the short version of using Qt to query a web API. First, we have to create a Q core application, a pointer to a Q core application. You can also use the Q event loop. And then basically we use the Qt slot objects and slots connection approach here to basically the second connect method here. It says when the Q Network Access Manager receives the finished signal, run the following function. Now the following function is actually a C++ lambda function, which means it's defined in place. It's an anonymous function. So this is established at runtime, but it doesn't run until that finished signal is actually received. And as you probably know, the way C++ lambda function works are that they start with the square brackets, and those are the local variables or objects that you want to pass into the lambda function. So lat long result, which is the result object I created in the previous slide, reply, which I'm going to use inside this lambda function to push the reply once we push the result, that is, once we get the data. This, which actually I don't think I used below, but I'm passing it anyway. And then in the normal parentheses, there's the Q network reply pointer to a Q network reply. So when this runs, we're going to have a pointer named MSG, which is the reply from the network. And we can use that MSG to see if we actually got a reply, and then parse it. In the next couple of screens, I'll show that. So the end of the lambda function is where we have the curly brace, and then the parenthesis and the semicolon right after that. All of the work is done right here. It's represented by the ellipse. And basically, the final 3 lines here are the other bits that you need to do to use the Qt, these Qt classes to access the network. So you create a request with the URI. That's the URI I created previously that uses our Latin long. And then in the manager, you say get the request. And then on the app, which is the Q core application, you exec it. Again, that could have been a Q event loop. So there's that. You can, again, look in the branch and see the full stuff, in sequence. So now we're going to look at inside that lambda function. So this is the code that runs, and it receives the MSG, the pointer MSG, which is what you get back from the web query. So the first thing it does simply is it sees whether or not there's an error. If there is an error, then it basically, there's a Q critical log, which basically means that the scope will stop. If there is no error, then we use the read all method to populate response, which is a Q byte array. A couple of steps here you got to get through to get from the response to the network into JSON, which we can actually parse and read. Basically, excuse me, read all into the response. We have a Q byte array, and then we try to create a QJSON document from that. And basically, if there's an error, then we have another Q critical bug, and we return out of the lambda function. So assuming everything went right here, there was a network reply, and the response can be turned into a QJSON doc. We now have our DOC, our QJSON doc object, which we just can parse using the QJSON support that's in Qt. So I convert the doc into a QJSON object, and then named OBG, and then basically I get the two fields that I happen to know are in that object because I first ran the web query just as a URL in the browser, and I looked at the JSON that came back, and I saw, okay, the object has a country code, or it has a country name, so I just create Q strings for those. Then I populate my summary string using the same approach as previously, and then in my result I populate the summary field with my summary string, set a URI, always required, and I push that result using the reply object that was passed into the lambda function. And that's the end of the lambda function. So there's a simple and straightforward, relatively simple, querying of a web API using the lambda function and pushing the result to the scope. Okay, so other resources, obviously we have the API docs. There's a link, and there are docs and tutorials on developer.ubuntu.com in the scopes area. There may be more resources, I'm not quite sure. Okay, and that is the end of my presentation. And I think now I can see if there's any questions. So I'm looking in the IRC room, not seeing any questions. If there are any, or comments or whatever, that's cool. In the meanwhile, I think I'm going to demonstrate something I wrote, which is called ScopeData. I actually forked something out of the Unity Scopes API branch. And there's a tool there called Scopes Client, which allows you to, at the command line on your device, basically launch a scope by its ID, and it outputs kind of unformatted just strings of data about the scope. And I converted that into a tool called ScopeData, which is on Launchpad, just scope-data. It's a project, and allows you to run a scope and basically show lots of different types of information about it from the command line. I'll give you an example. So, let's see. I need a screen share. Hang on. This is very useful for debugging and understanding your scope, generally speaking. Let's see if this is the right terminal. Okay, I think it's the one. So I'm going to make this text a little bit bigger. And as you can see, the prompt shows that I'm actually logged into the device. And if you build ScopeData project, you get an ARM hardfloat executable if you build it, in an ARM hardfloat chroot, and it's named ScopeData. So the first thing you can do is you can use the -list argument to just list scopes that are registered on the local system. So for example, I can list and grep for location, which is the current scope. Oops. There it is, com demo scopes location. That is the fully qualified name of the scope, and includes, the first part is the click package name, com demo scopes location, then underscore location, which is, you can call it the app within the package. Click packages can support multiple quote apps, each of which has a separate click hook section. But in order to use ScopeData, you need to use the whole thing. So let's do this. Let's go ScopeData and put in the fully qualified name. Let's show some more information about it. Let's show the meta information. This is the information that is derived from the scope ini file. As you can see, interestingly, it doesn't show the location awareness key. Not sure why that is, but it does show a lot of other good stuff about it. So let's now see the scope categories. So these are the categories that are defined in the scope. There are two, presented as proper JSON. Location API. This is the first one, in which I hard-coded the results, and it shows the renderer template. It shows the title, and basically shows everything. And here's the second one, country info. This is what we used to query the web, to show the web API results. Okay, you can see actual results. So this runs the scope. Here are all of the results as JSON. So here we can see the category it's in, category ID. We can see the summary field, which was defined in the JSON template, and its value. And we can show the URI. So here are the results. We can show, well, normally you can show preview information, but this scope doesn't have any preview stuff. Although this shows the help. Okay, so there we go. That may be of use to someone. Ed Capex. Were you talking to me when you said, could I see on your emulator? I'm quite sure what you mean. I do have an emulator. I haven't used it in a couple of months, so I don't think I can fire it up right now. But there's no reason why this scope won't run, in the IDE on an emulator. It's just a scope. Okay, well, I think that's about it. So, seems like there aren't any more questions. I'd like to thank anyone who is listening, and that Mike joining?
Yeah, I'm here.
Okay. So, anything else?
Nope. Thank you, Kyle, for giving this presentation. I think we've got some more that are going to be coming up next week. Same style, only they're probably going to be on summit.ubuntu.com's schedule instead of just on Ubuntu On Air. So thank you, everyone, for watching. Thank you, Kyle. I also want to thank David Calais and David Planella, who gave workshops earlier. And if you missed any of those, you can go find them on the Ubuntu On Air YouTube channel and rewatch them anytime.
Okay. Thank you, Mike.
Thank you.
Cheers.
Bye, everyone.